Hi students, in this video we are going to discuss applications of stack data structure. So what is a stack data structure? Stack data structure means last in first out data structure. If you have not seen my video on stack data structure, you please see the video and come back to this video. Then it is easy to understand the applications. So generally, what are the applications of stack data structure? This stack data structure is used in the concept of recursion and balancing of symbols. Balancing of symbols are nothing but like open parenthesis, close parenthesis, open curly brace, closed curly brace, open square bracket, closed square bracket. Okay, like that. The symbols balancing. And then in fixed expression to postfix expression, and then evaluation of postfix expression. Evaluation of postfix expression. So now coming to one by one. In this video we will discuss the first two applications. In next videos we will discuss these applications. Coming to first one, recursion. What is meant by recursion? Recursion is nothing but function calls the same function. Function calls the same function is nothing but recursion. But this recursion concept uses the stack data structure. This recursion concept uses the stack data structure. So how it is going to use? For example, I want to calculate a factorial of 4. This 4 in mathematics generally we will represent like this now. So 4 factorial. That's 4 factorial is nothing but 4 into 3 factorial. See, to calculate factorial again what we are using? Again we are using 3 factorial. Okay. So now suppose now this 3 factorial is nothing but 3 into 2 factorial. So one number factorial we want to calculate. For that again another number factorial we have to calculate. Function calls the same function. Again 2 factorial is nothing but 2 into 1 factorial. So like that. So this recursion concept uses a stack data structure. See 4 factorial. This 4 factorial is nothing but 4 into 3 factorial. 3 factorial is nothing but 3 into 2 factorial. 2 factorial is nothing but 2 into 1 factorial. So like that, for every function call, suppose if we have considered factorial of a given number, for that in the recursion the logic is n into factor of n minus 1. In the same manner 4 factorial is nothing but 4 into 3 factorial. So those functions are one by one pushed into the stack like this. 1 factorial value is 1. Okay. That value will be returned. So 2 into 1 it is 2. 3 into 2 6 will be returned here. 4 into 3 factorial is 6. 4 3s are 12 will be returned here. So 3 2s are 6, 6 4s are 24. So 3 factorial is 6 now, 4 6s are 24. That 24 will be returned here. So for every function call, that function call is pushed into the stack. After that function call completion, that means execution of that function completion, that function will be popped from the stack like this. 4 factorial, then 4 into 3 factorial, then 3 into 2 factorial, then 2 into 1 factorial. So 1 factorial the condition will fail. So that's why here it will come back, again come back, again come back. The final value is 24. Like that, recursion concept uses a stack data structure. Similarly, our second application is balancing of symbols. For example, for this also, how stack is used to check balancing of symbols. Now, for example, I'm writing simple code. For example, in main function, open curly brace, some integer a, if a equal to 5, printf a equal to 5, else printf a is not equal to 5. For example, if this is the code. Okay, so whenever you are compiling, so the symbols will be, open symbols will be pushed into the stack. What does it mean? Now see, if it is open parenthesis, now that open parenthesis is pushed into the stack. Closure parenthesis, what is top of the stack? So open parenthesis. Now closure parenthesis occur. That means these two symbols are balanced. Now next, what is the symbol? Open curly brace. Next, what is the symbol you got? Open parenthesis. So open parenthesis. Again, what is the next symbol? Open parenthesis. Then what is the next symbol? Closed parenthesis. What is the next symbol? So now here it is closure parenthesis occur. Now open parenthesis, closure parenthesis are balanced. So it they will be removed from the stack. So now again open parenthesis, this one. Then again closure parenthesis, and then closure parenthesis is nothing but again this open parenthesis and closure parenthesis are popped. Now see, closure braces occurred. So now what is top of the stack? Open parenthesis. Now what is the symbol you got? So closure curly brace. So both are not matched. So you will get an error. So that means compiler is generating an error. For example, here you have parenthesis. Then what will happen? So now take the stack data structure, open parenthesis. Now closure parenthesis occurred now. So now top of the stack is open parenthesis. That means these two are balanced. So you can remove this. Next, open curly brace. After that, open parenthesis. Then closure parenthesis occurs. Whenever closure parenthesis occurs, it checks for open parenthesis. So it will be popped from the stack. Again, next open parenthesis. Again closure parenthesis. Whenever closure parenthesis occurs, this open parenthesis will be popped. Again open parenthesis, closure parenthesis occurred, this will be popped. Then closure curly brace, open curly brace. So program is ended, stack is empty. So then no errors in the program. So if we are getting, then definitely compiler will generate the error. So these are the two applications of stack data structure. Remaining two applications we will discuss in the next video. Thank you students. Hope you understand. If you have any doubt, please post your comments or questions in the comment box. Thank you. Bye. Have a good day.